Okay, so in the previous class, we finished VXLAN. We are done with the Nexus module as well. The next module that we're going to be discussing about is the ACI module. So ACI stands for Application Centric Infrastructure. What exactly is ACI? So any document, any video that you read on ACI, the first statement that you always see is ACI is Cisco's answer to SDN. Any document, any video that you watch, first statement always is Cisco's SDN. This is Cisco's answer to SDN. What is SDN? So SDN firstly stands for Software Defined Networking. Okay, what exactly is SDN? So see, normally what happens is in a traditional network, and you know that all networking devices, they will have three types of planes. You have the control plane, data plane, management plane. All right. Now, in a traditional architecture, the devices are connected from one device to another device. Like you will have a certain topology that you're going to be following, right? Now, I'm not talking with regards to SDN. I'm talking about the traditional deployment. Okay, traditional deployment of your switches, of your networking devices in your network. So when you have connected all of these devices, so first of all, what is control plane? Control plane is nothing but the decision maker of your device. Decision maker means what? So this particular component of your device basically decides how the traffic should flow, where it should send the traffic next, right? So for example, your routing protocols are considered as control plane protocol. Okay, so excuse me. So what happens over here is your control plane, for example, like I said, routing protocols, for example, OSPF, BGP, EIGRP, that's exactly what they do, right? They have a logical topology and they know if in case I'm receiving any traffic for a particular destination, how the traffic should be sent, what should be the next hop, how the traffic should be forwarded. So these decisions, these important decisions as to how and where to forward the traffic is what is taken care of by the control plane. What is data plane? Data plane is nothing but the actual movement of traffic. Control plane makes the decisions of how the traffic should flow. Data plane does not have any decisions. It's just going to send the traffic based on the decisions made by the control plane. Next is management plane. Management plane is nothing but how it is that you manage that particular device, which we had discussed when we were discussing about the Nexus hardware, right? So all of these devices in your network in a traditional environment will always have these three planes. Like any networking device you take, any switch, router, firewall, whatever it is, they will always have these three planes accordingly. They'll have control plane, data plane, as well as management plane. Now, when you have a traditional environment, if any of these devices goes down, it is definitely affecting the control plane decisions of the rest of the network, right? The rest of the network is definitely going to get affected by this particular failure, right? So this is how SDN was born. This is how SDN was born. So what exactly is SDN? SDN is nothing but, to put it in simple terms, switch management, centralized switch management. Okay, so centralized switch management means, centralized means you will have a controller device from where you can manage your switches, and how many ever switches you have, you can configure the policies for the required switches from the controller, and then you can apply these policies to any switch of your choice. Right? Now, what about the control plane, data plane, and management plane? So your controller, this is what is called as SDN controller. See, I'm not specifically talking about a particular SDN. What I mean by that is, ये जो SDN concept है, that is available by different vendors as well. Okay, so generally I'm just talking about it. So you have an SDN controller. The SDN controller has the management plane as well as the control plane, whereas the data plane resides on the switches. The controller is having the management and the control plane. This is from where you manage the switches. This is from where you create the policies for the control plane for your switches. And only the data plane resides on those devices, on the switches. Okay, so this way what happens is, again I've just drawn two switches, but you get the idea. Jitne bhi switches hai that you are managing from the controller, from the centralized controller, even if any of those switches goes down, maybe 1, 2 or 3, whatever, like how many ever switches go down, the control plane, which is the most important, is not going to get affected because your controller is up, because your controller is active, right? The networking decisions, the network changes are not going to happen, or it's the other switches are not going to get affected by the failure of a particular switch. Okay, so this is what actually SDN is. Again, we are not going to be talking in detail about SDN. This is just the gist of SDN that I have told you. The detail of SDN is actually in the CCI enterprise field, where you will be talking about SDN and then eventually moving to SD-WAN and XD access. All right, but over here, I'm just telling you what generally SDN is. So this particular SDN concept, it is an open standard concept. So that's why I told you different vendors have their own variants of SDN. And Cisco's variant of SDN is ACI. Okay. Now, with this, there is one more thing that I have to tell you. ACI, yes, it is a type of SDN. I would say it is a variant of SDN. It's like a flavor of SDN, but it is not exactly SDN. It does not follow exactly this particular concept. How come it's not following this exact concept? I will tell you, like just a couple of minutes, I will tell you what exactly is happening. But for now, this is what is SDN. The data plane just lies on the switches, and your controller has the management plane as well as the control plane. The controller has all of the control plane decisions. If any of those switch goes down, control plane does not get affected. Routing, I would say the forwarding of traffic is not disrupted. Okay. Now, with this, what exactly is SDN? So, like I told you, sort of SDN, but not exactly. I'll come to that a little later. Now, UCS, if you remember, this was called as stateless computing, right? Why was UCS called as stateless computing? UCS technology is nothing but where you are centrally managing servers. This is to do with your servers. Servers are nothing but compute devices, right? And how many ever servers it is that you're using in a UCS environment, all of those servers are stateless. What does it mean by stateless? It means कि जितने भी servers है in your UCS environment, those servers do not have any configurations of their own. You will have to configure it from the controller. In UCS, I hope you remember, the controller was called as the fabric interconnect. So yahan se you had to create your policies, and then you had to push your policies towards your required servers. Right? So this is what UCS was: centralized management of servers. And your servers or your compute devices that you were using in UCS, they were all completely stateless. That means that they did not have any configuration of their own. Okay. Now, ACI. ACI, like I told you, is nothing but management of switches, right? ACI can also be called as stateless networking. ACI can also be called as stateless networking. It's called as stateless networking because obviously here you are dealing with switches which are nothing but networking devices. And how many of the switches you're using in an ACI environment, all of those switches are stateless. Again, the same meaning. They do not have any configuration of their own. You will have to configure it from the ACI controller, which I will talk about in just a couple of minutes. So ACI controller say you will have to create your policies and they are pushed to your switch of desire. Okay, next. ACI follows something called as policy-driven model. ACI follows something called as policy-driven model. It is basically automation and orchestration model. So what is this? This is nothing but, like I told you, you have your ACI controller and you have your switches. How many ever switches you're using. We will talk about the switches also. Just a couple of things that I want to cover before we move to the components of ACI. Okay, so what happens is, like I told you, how many ever switches you are using in ACI fabric. So from now, please remember, anytime I say ACI fabric, that is nothing but your switches. How many ever switches you're using in ACI now, those are called as ACI fabric. Okay, so how many ever switches you're using in ACI fabric, like I told you, they are all stateless. That means that they do not have any configurations of their own. Whatever you want, you'll have to configure it from the controller. Okay, so basically, I would say the controller is your policy device, and these are your normal, your switch level device. Okay, the policy device, as in controller, is, like I told you, from where you create your policies. However your leaf or your, sorry, however it is that your switch should behave, right? You're creating all the policies, you're creating all the configurations for your switches from the policy device, which is nothing but the ACI controller. And those policies are then going to be automated. Automated means, see what happens is, if you remember, I hope you remember, UCS mein controller was fabric interconnect, right? When you created the policies for your server, what did you have to do? You had to manually push those policies. What I mean by manually is that what you had to do is you had to create something called as the service profile, and this service profile you had to associate to your server, sort of like a manual push, right? Jitne bhi policies hai, you're calling everything under something called as service profile, and this service profile you had to manually push onto your selected server, like whichever server it is that you wanted. That's what I mean by when I say manual push, right? But in ACI, excuse me, but in ACI, it's not that way. In ACI, as and when you create the policies for any of your switches, the policies are automated. Automated means, as and when you create your policies, they are automatically pushed. You don't have to manually push them. You don't have to create any policy which is, similar to a service profile or anything like that. As and when you create your policies for the switch, any switch in your entire ACI fabric, automatically the policies are applied only to that particular switch. You don't have to, like I told you, create any such service profile sort of a policy, and call the other policies and then associate this to your switches, nothing like that. Okay, so this is what is called as automation. As and when you create your policies, policies are automatically applied to the relevant switches for which it is that you're creating the policies. And of course, also another point is, policies जो हम create करते हैं, they are human readable format, right? Human understandable format, obviously. We create policies because we know their meaning. That's how we create those policies. when these policies are automated, when these policies are automatically applied to those particular switches, obviously the policy again automatically gets converted into device readable format. And then the policies become orchestrated. What is orchestration or orchestrated? See, like for example, you might have seen like an orchestra event, right? Maybe on TV, you might have attended it live. Orchestra to dekha hoga. There are a lot of musicians, right? There is probably a guitarist or a pianist, somebody playing the flute, and a lot of different instruments. And in between all of those musicians, there's always one person. You might have seen one or maybe two people standing right in between, and they will have a wand in their hand. They will keep waving their wand, right? Up and down, anyway. So as the wand goes up, their pitch goes higher. As the wand goes down, their pitch goes lower. So basically, that person who is standing in between, this person is called as an orchestrator. He is making those rules. He is telling the musicians how to play those music, how the pitch should go, how the music should happen. Okay. So over here, that's exactly what is happening. When you're creating the policies, you are basically telling the device how it should behave. Okay. So as and when you create the policies, like I told you, they are automated. That means that they are automatically applied to the appropriate switch. And according to whatever it is that you have configured for that particular switch, the switch will immediately start behaving in that particular way. Policy is nothing but rule only, right? You are creating a certain rule for that particular device to behave a certain way. So as and when you create the policies, as they get automated, they are orchestrated as well. The device behaves according to the rule, according to the policy that you have applied to it. Okay. So this is what is called as automation and orchestration. Please make note of this. Next, coming to components in ACI. So major component, of course, is your switch. Whenever you're using ACI, please remember you should always be using your switches or connecting your switches, I can say, in a two-tier architecture. Okay, you should always be connecting your switches in a two-tier architecture, leaf and spine architecture, however you want to call it, clause architecture, collapsed core architecture. It all means the same thing. Always connect your devices in a two-tier architecture. Next thing is, can I use any switch of my choice? No. You should use only ACI capable switches. And which switches are those? Those are specifically only Nexus 9300, 9500 devices. We had spoken about both of these hardwares when we were doing the Nexus hardware. When you talk about the Nexus 9000 devices, the 9000 family, there are actually a lot of series. You have 9200, 9300, 9400, 9500, 9600, 9800 as well. But not all of these devices support ACI. Only 9300 and like I said, 9500 devices can be used in ACI environments. The rest of the series jo hai, they can only be used in a Nexus environment. What I mean by Nexus environment means on these devices, you can only have like Nexus operating system installed and they can only be used in Nexus environment, like maybe to run your normal, right? Your VPC or your VXLAN, your normal routing protocols. That's it. When you're using your devices in ACI, these devices will be installed or will have ACI operating system present on them. Okay, so your 93 and 9500 devices are capable of both actually. As in, obviously not simultaneously. Please remember this also. On one device, like or one switch, right? 9300 or even 9500. This one switch cannot be used in both environments. You cannot use it in both Nexus environment as well as your ACI environment. Both the operating systems you cannot install on that particular switch simultaneously. Either you use the switch in a Nexus environment for your Nexus deployment, or you use the switch in an ACI environment for your ACI deployment. You can't do both at the same time. Okay, so 9300, 9500, these devices, they are capable of both. Like Nexus OS bhi chala sakte ho, 95, you can also use them for ACI. Now, two-tier architecture is nothing but your leaf and spine architecture, right? So can I use any of those devices as my leaf and spine? Like for example, see, like in a normal Nexus environment, I'm saying, normally, yes, we do use 7Ks or even maybe 9Ks as our spines. And we normally use 5Ks as our leaves, right? You can do it the other way around also. 5K can be used as the spine, 7K or 9K, for example, can be used as leaves. It depends on your connectivity, how it is that you have connected. But you can do, normally it's not done. Normally your spine devices are kept as the higher end devices. Normally this is not done, but it can be done. I've tried it also. It can be done. It makes no difference. Okay. It depends on your connectivity, which device it is that you're using as the leaf and which device it is that you're using as a spine. So can I apply the same concept over here in Nexus as well? Can I use any of these devices as my leaf and spine? No, you'll have to check. Okay, like for example, 9300 devices, I hope you remember, these are fixed switches. Some of these devices are, for example, 9336PQ, 9332, fairly new. It's not extremely new, but fairly new device. 9364C. All of these can only be used as ACI spines. You cannot use them as leaves, only spine. There are other switches in this, for example, 9396 PX, you have 9372 PX as well, right? All of these devices you can only use as leaves. 9500 devices. I hope you remember these also. These are modular devices. So how do we know whether this device is a leaf or a spine? I hope you remember there are actually 3 models in this. You have 9504, 8 and 16. So how do we choose these devices? Whether it should be used as a leaf or a spine? This purely depends on your line card. Okay. I hope you remember we had discussed about the line card as well. So 9500 series ke liye, right, for the line card, there are again different variants. You have the 9500 series of line card, you have 9600 series of line card, 9700 series of line cards also. 9500 series line cards, they don't support ACI, they only support Nexus. 96 and 9700, certain line cards, they support Nexus, certain line cards, they support ACI. And in ACI again, certain line cards only support the leaf functionality, certain line cards only support the spine functionality. This you will have to check the data sheet because there are so many line cards, so many line cards. 96 variant maybe 9700 variant also. Lot of line card variants are there, hardware models are there, like the line card hardware model. Okay, so you have to check that certain line cards, they will only behave as leaves, certain line cards, they will only behave as spines. So you have to check which line card it is that is behaving as a leaf or a spine. Now, when I say behaving as a leaf or a spine, how does the device or how does the line card behave as a certain leaf, as a certain spine? Why can't, like we did in Nexus, for example, just use, like a random device based on the connectivity to be used as the spine as well as the leaves? Why can't we just do this based on connectivity? You cannot, because like I told you, the certain devices will only behave as spines. Certain devices or line cards, I can say, will only give you the leaf functionality. Certain devices or line cards will only give you the spine functionality. Okay, now how is that functionality present? Like, how do we know? So actually what happens is there is a hardware chip on the device or even on the line card. Again, it depends whether you're going for the fixed series or the modular series. Okay, so the hardware chip, that's actually a Broadcom chip. I will write it over here. If your device or your line card behaves as a spine, only as a spine, it will have a chip which is called as ASE, Application Spine Engine. And if in case your device or your line card behaves as a leaf, it is because it has application leaf engine. These are hardware chips. It's not software based. It's not version based. Okay. So it's the presence of these chips on the device or on the line card that gives them their ability to have that leaf functionality or spine functionality. And those devices you have to use accordingly. For example, 9336PQ, I have to use it as a spine only. Because these devices, they have ASEs. These devices, they have ALEs. I cannot, mix and match. Okay. So I have to use, for example, 9336PQ as a spine only because it can only give us the spine functionality. It cannot give us anything else. And for example, 9396 and here also a 9396 we can use as our leaves. Okay. So this is about the first component, which is to do with your switches. Next component is to do with your controller. This controller in ACI is called as APIC. APIC stands for Application Policy Infrastructure Controller. This hardware is actually a UCS C series rack mount server. RMS is rack mount server. Okay. Now that does not mean कि you get कोई भी like UCS में कोई भी C series server and you install ACI operating system on this and it will start working as APIC. No, no, please don't do that. It will not work. Okay. For the APIC, you get a separate hardware, but it belongs to the C series family. It's a separate hardware, it's a separate server controller, but it belongs to the C series family. Okay, so don't just buy a normal C series server and then install ACI operating system. That is not going to work. APIC का एक अलग से hardware आता है. So you have to, like when you're placing an order, you have to choose, you have to say that you want an APIC itself. Because that particular device, I'll show you, it looks a little different. The ports that are present on the APIC are different when compared to the ports that you get on a normal C series server. But it does belong to the C series server family. Okay, so let me just show you an example of your APIC. Okay, so over here, you can see this is what an APIC looks like. Okay, this is what an APIC looks like. Like I said, it does belong to the family of the C series, of the UCS C series server. All right, and the rear end of the device looks something like this. It has a couple of ports. I'll explain these ports, don't worry. I'll explain what these ports are used for. But this is how the APIC looks like. Now, couple of things. When you are placing an order for your APIC, there are actually different variants that you can choose from. You have a medium variant and you have a large variant. What is this medium variant and large variant? So, when you're using your controller will be connected to the switches, how they're connected, what cable is used. Don't worry about that. I will talk about the connectivity, okay? I have some switches over here like this. I've just taken two leaves and this is one spine. Okay. Now, when you're buying an APIC, right? Like I told you, medium and large variant. How do you know which variant it is that you should be choosing? This depends on the number of endpoints. What is endpoint? Endpoint is nothing but end host device. What exactly is end host device? It can be any other switches, routers, firewalls, load balancers, intrusion detection systems or intrusion prevention systems, right? Anything else like your storage devices, your server devices, etc. The rest of the network, to put it in short, the rest of the network, बाकी जितने भी devices है in your network, all of them will be connected like this towards your leaves. These are called as end hosts. In ACI language, these are called as endpoints. Okay, so depending on how many endpoints you have connected in total, you choose medium or large. Now, please remember, if in case you have a server, let's say I have a server connected, server pay, I have created a couple of VMs. Each of these VMs that you create, these are also called as endpoints. Okay, so it is inclusive of this. Count the number of VMs, count the number of virtual machines that you are using as well when you want to make a decision whether you want to go for medium variant or large variant. If you're going for medium variant, it supports less than 1,000 endpoints. And if in case you're going for a large variant, more than 1,000, how many ever endpoints you have, you can go for large variant. Now, what is the maximum number of endpoints that we can use in the large variant? This I'm not sure because none of the documents mention anything as such. They just mention if in case you have less than 1,000 endpoints, go for medium. If you have more than 1,000 endpoints, go for large. How many maximum endpoints I can have in large, like 1,000 to what, right? More than 1,000, okay, but until where? Like, what is the limit? That it's not mentioned in any of the documents. But if in case you have more than 1,000 endpoints, you can go for the large variant. Okay. Now, another thing, whenever you're buying your APIC also, so you might see like M2, M3, yeah, L2, L3, recently is M4. You might be able to see something called as L4. So what is this? See, M is nothing but medium, L is nothing but large. But what is this 2, 3 and all that? That is nothing but your generation. Okay. This is generation 2, generation 3, generation 4. So it's up to you which generation it is that you want. Some of these generations, I think the M2 generations officially are end of sale, but you might still get it, but it is officially end of sale. Okay. The latest ones, or I would say the available ones, are your third generation as well as the fourth generation. So in this also, again, they will each have their own technical specifications. So it's up to you which variant it is that you want to go for. Okay. Until here, everybody has understood whatever we have discussed? Just until here. Okay. Moving ahead. Coming to the connectivity. So, as usual, leaf and spine architecture hai. That means how many ever spines you have, how many ever leaves you have. All your spines, so let's say these are my spines, these are my leaves. How many ever spines are there? They must be physically connected to all the leaves this way. Okay. Can't we have spine to spine or leaf to leaf connectivity? Absolutely not. You cannot have a spine to spine or even a leaf to leaf connectivity. Now, what if we want to configure VPC? So first of all, is VPC supported? Yes, VPC is supported, but VPC is supported only on the leaf level. Okay. Now, if in case you want to build VPC between leaf 1 and leaf 2, VPC के लिए you normally do require pure link and pure keep alive, right? If this particular topology was used in a Nexus environment, like for example, we were discussing VXLAN, right? You can have actually leaf-to-leaf connectivity for your VPC. If in case you are configuring VPC, only then you can have leaf-to-leaf connectivity. Okay, so you can have leaf-to-leaf connectivity if you are configuring VPC for your pure link as well as your pure keep alive connections. But over here in your ACI network, in your ACI environment, absolutely prohibited. You cannot have any physical connectivity between the leaves. Then what about the pure link and the pure keep alive? They will go through the fabric. They will go through the fabric. That means it will use any of the spines to exchange those messages, but you cannot have a direct physical connectivity between the two leaves. And I have actually tried this. If you plug in a cable from one leaf and, plug it into another leaf, the port, whatever port it is that you're using, immediately goes down. Immediately. And it will never come up until and unless, of course, you plug it out. Okay, so leaf to leaf connectivity, no matter what, even if you are configuring VPC, is not supported. Pure keep alive and pure link, the messages are always exchanged through the fabric, like through the spines. How many ever spines you're using, it can go through any of the spines, depending on the ECMP hashing algorithm. I hope you remember what is ECMP hashing algorithm also. So ECMP stands for equal cost multipathing or equal cost multiple paths. What is the meaning? Equal cost multiple paths means if I want to reach from one leaf to another leaf, let's say I have leaf 100 over here, right? From leaf 1 to leaf 100, I want to send traffic. I have multiple paths to choose from. I have multiple paths to choose from. I can send the traffic through spine 1 like this, or I can also send the traffic through spine 2 like this. But no matter where I'm sending my traffic, the distance to reach my destination, the cost to reach my destination is the same. That is what is meant by equal cost multiple paths. There are multiple paths for me to reach from one point to another point. No matter which path it is that I take to reach the destination, it's the same. The cost is the same. The distance is the same. Okay, so then how is this decision made? Again, ECMP actually follows an internal algorithm which is called as the hashing algorithm, similar to your port channel hashing algorithm. So depending on the spine connectivity, spine availability, not connectivity, I'm sorry. Depending on the spine availability and, the usage of that particular link, hashing algorithm chooses ki spine 1 say you have to send or spine 2 say you have to send. Or how many ever spines you have, spine 3, spine 4, etc. In spine and leaf, can't we have spine VPC? No, sir. You cannot have spine VPC. In an ACI environment, your VPC is only and only supported between the leaves. Okay, so if you want, you can put leaf 1 and let's say leaf 100 in one VPC domain. So you can have a VPC domain between leaf 1 and leaf 100 like this. There's no physical connectivity na, so there is no such requirement ki VPC ke switches jo hai, they have to be, like close connected so that you can have the physical connectivity, nothing like that, because there's no physical connectivity here between the leaves. So leaf 1, wherever it is, leaf 100, wherever you have placed it on your rack, you can still have VPC configured between them. On the spine level, it is not supported. It will not even give you the option to configure it or choose it, I would say. Okay. Next, how many spines, how many leaves can we use? You can use maximum of 16 spines. Maximum of 16. Why 16 only? Because ECMP hashing algorithm, right? ECMP supports only up to 16 spines, not more than that. And leaves, you can go up to 200, 300, 400 leaves as well. It depends on your ACI version. right? So if you open any ACI version ka ye scalability matrix na, let me show you an example. So if you open any document on your ACI scalability, over there it will be mentioned ki how many matrix, how many leaves, how many spines are supported. So if we go here, this is, you can see, this is the scalability guide for this particular version, 4.2, 4.22, okay? And over here, if you go down, you will be able to see how many leaf switches are supported, how many spine switches are supported, maximum over 6 in this particular version, okay? What is this pod? What is meant? What is this pod and what is this fabric? I'll tell you that as we move ahead a little bit. Don't worry about that. Okay, so you have to check the scalability guide. That will give you key how many values, how many such objects you can have, how many leaves, how many spines, how many controllers, APIC controllers, and these all are your logical configurations. So I don't worry about this. I'll talk about this. So you will be creating a lot of, like tenants and VRFs, contracts and filters, EPGs, very, very important configurations. All of these are. So jitne bhi hai, like these are all logical configurations. These are all, I would say, policies. These are all policies. Okay. So how many such policies you can create? That is also mentioned to you, right? How many tenants you can have? 1,000. Yeah. Again, it depends. If in case you're using like a large L3 version, generation 3 fabric, then you can go for 3,000 VRFs. How many contracts, how many filters, how many EPGs. So it depends from version to version. Okay. So whenever you're using ACI, make sure that you're checking your ACI version so that you can then accordingly, first of all, invest on the hardware devices. And then you can come to the policies and check how many policies it is that you can create in total. Okay. Next, this is about your connectivity between the leaf and spine. Where is the controller coming here? How are we connecting the controller here? Always remember, आपका जो controller है, your APIC, right? Your APIC can only get connected towards the leaves. You cannot connect your APIC, you cannot connect your controller towards the spine. It's not supported. Like I told you earlier, how does the APIC know whether it is connected to the leaf or a spine? Because of the presence of the of that chip, right? ALE, AAC. That is what tells the controller कि ये जो connected है, that is a leaf, that is a spine. So don't even try to connect your spine to the APIC. It does not work. Always make sure that your controller is connected only to the leaf. Now, even for the connectivity, I'll talk about it. So there are actually 2 ports present on the APIC, only 2 ports that you can connect towards your leaves. And these 2 ports must be connected to 2 different leaves. Please remember that. Don't connect it to the same leaf like this. This is not supported. Make sure that the connection is towards 2 different leaves. It can be any 2 different leaves. Okay. What about for my other leaves over here? So I do have some other leaves, right? How do I connect them to the controller? You don't have to. It's not mandatory कि every leaf has to be connected to a controller. There is absolutely no such rule. Okay. With this particular connectivity itself, your controller can manage all of your spines, how many ever spines you have, and your controller from here only will be able to manage how many ever leaves it is that you're using. There is no rule that the leaf should be connected to an APIC. So you don't have to invest on multiple controllers. With this, there are a couple of ports on the APIC. So like I said, there are two ports that you can connect only towards your leaves. These two ports are, they have like a number, like an interface number, like 1/1, 1/2, right? Like that, your ports which are connecting towards your leaves, which are connecting towards your ACI fabric, those ports are 2/1, 2/2. You have two ports for your out of band, which is nothing but management port. Why are there two management ports? Does it mean that we can configure two management IPs? No, it's not for that. There is only one management IP that you can configure, but they have given you two ports. That is just for the sake of redundancy. This is your APIC. You have two management interfaces. You are going to be configuring only one management IP. But if in case the port fails, or maybe there's a cable failure or anything like that, for the sake of redundancy, they have given you the secondary connection as well. Okay, एक ही IP address होगा. There's only one management IP address per APIC. But there are just two ports that they have given you for the sake of redundancy. Next. Apart from this, there is one SIMC port. There is one console port. And there is one USB port. These are your different ports that are present on your controller. What is SIMC? SIMC stands for Cisco Integrated Management Controller. What is this exactly? Every Cisco server, every single Cisco server will have this particular port which is present on it. To this port, like when you boot your server for the first time, you might have seen like it will show you SIMC IP address. So when you boot your server for the first time, right, you have to always configure it with a SIMC IP address. Once you configure it with a SIMC IP, let's say 192.168.1.1. Okay. Once you configure it with a SIMC IP address, right? If you put this particular IP address on a browser, any browser, you will get access to SIMC page, SIMC GUI. It's a GUI. What is this exactly? This is used for your server management itself. Right? Server management itself. I hope you have seen that. Let me show you over here through the images. So this is what your SIMC page looks like. 1 minute. So when you're booting up your server, right? When you're booting up your server, after you have configured, 1 minute. Okay. So when you have booted up your server, after you have configured the SIMC IP address, you would have seen something like this. This is your SIMC IP address, whatever it is that you have configured. The setup page looks something like this. It will give you options how you want to configure. You want to configure it using DHCP or you want to statically configure it. You have both options. You configure the IP address, it will ask you for the subnet mask, it will ask you for the DNS, it will ask you for the default gateway. VLAN ID over here on the right side, that is nothing but your management VLAN. Whatever management VLAN you're using, you just give that particular VLAN over here. Once you're done, you can see at the bottom, there is this F10 wala key. That's to save your configuration. Okay. So once you save your configuration, आपका जो server है, which is over here, your APIC also, the same, it behaves the same way. Okay. So whatever your server is, including the APIC, once you save, your server will basically boot. Once it boots, again, you can just leave a continuous ping to this particular IP address. It will eventually start pinging. Once it is pingable, whatever SIMC IP address you have configured, right? You can put that on the browser and you will get access to your SIMC page. So over here only, this is what your SIMC page. This is the latest one. Old wala, if in case you are used to the old one or you might have seen a couple of years ago, this is what the SIMC page looks like. So here it's asking you for the username. Default username is always admin. What is the password? Where do we enter the password? In this particular setup page only, yahi pe there is this password wala option. You can see that. Okay. So whatever password it is that you set, the same password, you just put that and you log in. This is the older version. You can see it's old 1.4 and abhi maine jo dikhaya, that was the newer version of the SIMC GUI. This is what you see right now, the 3.x versions. Yeah, this is 3.0 3F. Oops. Okay, so your default username is admin. Password is whatever it is that you would have set up during the SIMC setup. And once you log in, this is what your login page looks like. So you will be able to see certain details about your server, certain details. In this case, we are talking about APIC. So you will be able to see certain details about your APIC. The name of your APIC, the serial number of your APIC, the product ID, the UUID. I hope you remember in UCS also, we had discussed about UUID. Every single server will always have a UUID, universally unique ID, universally unique identifier, right? That's your server identification. So every server will have this. What is the BIOS version, the power status, like everything about the server or for the server, you can configure, you can view from here. So once you have configured the SIMC IP address, if you want to take the console access of your server or of your APIC, you do not have to be on site. You can take it from anywhere in the world. You can take it remotely. All you have to do is just put this SIMC IP address of that server on the browser. Yahi say you will get the access to launch the console of that particular server. Obviously, the first time that you're setting up the SIMC IP address, you have to be on site because that's the only way. Aapka jo console port hai, whatever console port is there, console port, you have to connect it to your KVM, which is nothing but keyboard. This one, keyboard, video, and mouse. This is the full form of KVM, keyboard, video, mouse. Okay, so you just take the normal console access. For this, you have to be on site. Once the SIMC IP address has been configured, next time, say, you can take the console access from anywhere you are in the world. So this is what the SIMC IP address is used for. That's your server management wala GUI. Console port, USB port. So if in case, there are many chances there are some chances that, the ACI OS has been corrupted or, like there's a boot issue or anything like that. So if you, in case you want to reload the image, something like that, then you can always use a USB, like a bootable pen drive, and you can just stick it into the USB port. These are the two ports that you connect towards the leaves. Like I told you, only two interfaces are there. These are the only two interfaces, and you have to connect it to any two leaves. Don't connect it to the same leaf. I told you that. Okay, even if in case there are other leaves, if in case there are other spines, it's okay. From this particular connectivity itself, all the other devices can be managed. Okay, can we configure these in a port channel? Anything is supported? No. These interfaces jo hai, right? These interfaces 2/1 and 2/2, these interfaces are non-configurable. And also, please remember, these interfaces are 10 gig interfaces. Each I'm talking about. You cannot configure those ports. So there is no question of port channeling. Out of band ports. So just like you have 2/1, 2/2, आपके जो out of band ports है, these are 1/1, I'll write it here, 1/1, 1/2. And again, these are non-configurable interfaces. So you cannot put them into a port channel, nothing like that. Okay, they're just one-to-one, like dedicated interfaces that you can use to connect to your management switch. There are two ports, two management ports, yes, but you will only configure, oops, this one got erased. I was actually wanting to erase this part. Okay, so 1/1, 1/2. So there are two ports, yes, but you will only be configuring one management IP address, not more than that. There are two only for the sake of redundancy. Until here, everybody has understood?